So we have another problem. I think we can calculate this one. Crystalline silicon has a cubic structure. So again, SCC. Again, simple SC structure are the BCC, FCC, and your SCC. Your simple cubic structure. They are all cubic structures. The unit cell edge length is 543 picometer. The density of the solid is 2.33 grams per cubic centimeter. Calculate the number of silicon atoms in one unit cell. So I think the problem here, because anyway, we will just pinpoint the aim of the author is for us really to identify what is this, what type of a cubic structure is this. Basically, if we can calculate how many atoms in that unit cell, we can tell if it is a BCC, SCC, or an FCC. Okay, because these are the only simple ones that we're dealing with. So we can assume that the answer would be probably 2, 4, or 1. Okay? So I'm looking at the author's perspective. So may we copy? What is important whereabouts is the edge length, which is 543 picometers. So I can write it down. Um, the edge length, which is actually A in our case, that is a 543 picometer. Okay. So another which is important, the unit cell edge length, the density of the solid is 2.33 grams. So another given. So usually I call this whereabouts. Usually in elementary, we call this what is asked, what is given. So I already lump what is asked and what is given. So these are the given. A is 543 picometer. That is the edge of that length of the cube. And then we're given a density. Usually density is notated as rho in general chemistries and physics even. Rho is for density, and the density of silicon is 2.33 grams per cubic centimeter. Grams per cubic centimeter. So the question is how many atoms? Where the if we'll be looking at the formula, of course, that would be solution. I'll be analyzing it in terms of units. So dimensional analysis. So density, we just plug the density. Density is given, which is 2.33 grams per cubic centimeter. But for your simple cubic, that is an A cube. Wherein A is given here. Of course, you have to substitute that. And the upper part would be actually how many atoms? Number, maybe I can say number of atoms. How many atoms in the unit cell? And of course, if you already know how many atoms, you convert that divided by atoms per mole. So it's like a Avogadro's number which is reversed because of course what the unit here would be atoms and the unit of your Avogadro's number is atoms per mole. So you have to put here the atoms, meaning that is a reverse Na. So here is the Na, the Avogadro's number. This is the Na, Avogadro's number per 1 over Na. So that should be we will be using that. You can see from the units that it will give us the number of atoms. And then from Avogadro's number, atoms per mole, and then since the uh, element is given, which is actually silicon, you have to find the periodic table for silicon. Silicon, you have here 28085. So we should write that down. That's also a given. 2808. That is the molecular weight or the formula weight of silicon. Silicon that is 28 28085. 28.085 units is gram per mole. Okay, so I think we only have to multiply it here. Formula weight. So by that we can already find the number of atoms. So if this is given, this is given, this is given, we can use algebra to find the number of atoms. Of course, A would be multiplied by this, so that would be 2.33 grams per cubic centimeter would be multiplied by A. Of course, I will substitute now the A. 543, of course, times 10 to the negative 12. That is the picometer. Okay? In cube. And then we have to resolve it to cubic centimeter so that we can cancel this one. A cube will be multiplied by this. NA also will be multiplied by this because this is a divide. So going to that side, that should be a multiplication. So times NA. Okay? And then how about the formula weight should be divided here because that is a multiplied here. So that should be a formula weight, which is this one, 28085. So substitution again, 2.33 grams per cubic centimeter. Then we will 543 times 10 to the negative 10, just like we did with the other problem in the last video. So that negative 2 would be centi, and then it will go out. That would be a cubic centimeter now. Okay? So look at the video before this one, because it will tell you how come it becomes a cubic centimeter. And then we substitute our Avogadro's number, which is 6.022 times 10 to the 23. Unit is atoms uh, per mole. Take note of the unit. It should all be cancelled. What will remain is the number of atoms. Okay? So cubic centimeter is cancelled. How about the formula weight? The formula weight is 28085. 28.085 grams in every 1 mole. So mole cancel, mole cancel. Of course, you have to read the book. The concept of Avogadro's number. I think that is in chapter uh, the the LP before, as we compute the molecular weight based on the what I've given you LP1. I already gave that the Avogadro's number in multiplying. Of course, this anyway, that's a constant. That's just a constant. Um, the subject is already taking care of that in terms of concept. Then, so you can say that grams is also cancelled. So what remains actually atoms. So that's what the problem is. How many atoms? And there you have a unit of atoms. So now group all those at the top. So you can get a calculator and then more. We just plug those numbers times parenthesis 543 exponent negative 10 and then raised to 3, which is cubed, and then times 6.022 exponent 23, then divided by 28.085. So the answer is 8. So I told you the answer. So there are 8. Hmm. So I told you that there should be 1, 2, or 4. And then the answer is 8. How come? Okay. Because, but anyway, that should be the answer. That is the answer. 8. There are 8 atoms. So therefore, this is not one of those. Okay? I think this is the problem, that it is not one of those three types, which is the BCC, FCC, or SCC, BCC, and FCC. Because the answer really is 7.98 or 8. 8 atoms. So there's 8 atoms per one cell. How is that? Anyway, it should be it. May I pause? Um, I'll just make sure that the answer really is 8, 7.98. So as I've said, um, I'm just shocked that what I was what was I expecting was not the case. So again, maybe this you can use this one probably if you want to show that really the structure is not one of those three simple. Again, there are many structures. We've only considered three to make this discussion scratching the surface of what our crystalline solids are. Anyway, the answer is eight atoms. There are eight atoms, so it is not included in the SCC, which has only one, the BCC, which has two atoms per unit cell, and the FCC, which has four. So maybe this is not one of those because it has eight atoms. Okay, so thank you guys for listening.